Hello friends, welcome to my channel. Today we are going to talk about the very basics of machine learning modeling. Now if we go about the definition, so modeling is nothing but a collection of algorithms, different types of algorithms that facilitate implementing a machine learning based solution for a given problem. What model we want to choose depends on the use case that we are trying to solve. At a high level, the machine learning models can be categorized into supervised and unsupervised, and we are going to talk about the two most common models, one each for supervised and unsupervised. So that would be regression for supervised and clustering for unsupervised. So let's get into it. So supervised learning is learning with a teacher, learning a function, or basically by definition, if we want to understand supervised learning is basically we can think of a scenario where a teacher when the teacher wants to impart some information or impart some kind of concept to a student. What they do is they show a data set, or they show a set of examples which are already proven, and they have cause and effect, or kind of input and response kind of combination, where we already have some input and we already have a response. So it's called labeled data, where for a given set of response, given set of input, we already know the response. For example, in the slide, you can see there is one example where we have a data which is showing that based on age, what could be the height of a person. So if the age is 5, the height could be height is found to be 119.38 centimeters on an average, for example, and so on for age 7, for age 11, and so on. So what a supervised model would do is to basically understand this data set and extrapolate or form some sort of mathematical equation or some sort of analogy which will help the model to predict information or response for a value where the response is not known. In our example, for the age 8, we want to understand what could be the possible or average or approximate height. So after analyzing the data for whatever other data points that we have, we can identify based on using a supervised learning model, we can identify that the age for a child maybe of around 8 years could be around 140.98 centimeters. So this is how supervised learning works. Now there are two subcategories under supervised learning, that is classification and regression. So if we talk about regression, we are only going to focus on regression like I mentioned earlier. So if we talk about regression, how it works is instead of predicting a constant or a fixed value, regression basically predicts the outcome in a continuous range. So some of the most common regression methods are linear regression. Then there is something called decision trees, random forest, and neural networks. So we are going to talk in depth about all these things in the later slides. Okay, so now linear regression. This is the most common form of model that comes under supervised learning. And how it works is given a distribution of different points or observations or statistical data set that we have. We plot that data in, let's say, in a very simplistic way. If we have the data in a two-dimensional plane, so we plot that data and then we try to identify a line which is the closest to all the data points, or on an average the line which identifies or shows us the trend of how the data is moving when x and y coordinates change. So this is a very simplistic definition of linear regression. Now a linear regression could be not necessarily always it's going to be such simple scenario. It could be like we may talk about points or data distribution across multiple planes, or multiple kind of data points or multiple kind of features can combine to give us a model. So in that case, we have to deal with something called multiple linear regression or polynomial regression. The easiest way to represent linear regression is in 2 dimensions. That's what you see in the graph. So that is about linear regression. Now coming back to the next point, model is basically something called decision tree. Now decision tree is one of the most popular models that gets used, and it is very commonly used in predictive analytics, some sort of strategic planning or extrapolation or kind of recommendation, and overall machine learning in general. Decision tree is a very common use case or a very commonly used algorithm. Now at a high level, how decision tree works is it's nothing but it's some sort of a flow chart where each block, which is also called a node, has some sort of decision or choice to be made. So each block has some sort of a question that it poses, and there could be two possible outcomes for those points, and according to the outcome we choose, we move it further down on the tree. And all these nodes, they eventually form at basically there are levels in the decision tree. The deeper we go into the level, the more accurate the results could be. So what that means is, the more number of decisions that we make, the more closer we will be to our answer, or more closer or more accurate will be our prediction. But having said that, of course, this decision tree, we have to sometimes identify, or we have to sometimes get to an optimum value of the depth of the tree where we want to stop, and that is something that is a concept which we call pruning the decision tree, or basically cutting short the number of nodes or the depth of the tree, so that the algorithm should resolve and it should be a optimal solution which ends at within a specified or speculated duration. Otherwise, we can end up building trees which are really complex, and although they might be very high on accuracy, but computationally it will be really difficult to use them as a model. So yeah, that's kind of too much of information, but because we were going in that direction, I wanted to just highlight that. Now, important thing to know is the way or the level at which the decision tree ends. That's called the leaf node, or the final outcome node, or basically that node will give us what classification or category, if we are trying to categorize what classification or category the value ends up into. Like in this example that you see here, what we are trying to do is, based on some questions or some kind of properties that we identify of houses, like houses with more than 2 bedrooms, if it is yes, then it moves to this direction. If it is no, then it moves to this direction. And if the overall area of the house that is covered is more than 8,500 square feet but less than 11,500 square feet, then possible price of that house could be around 154k in dollars. Or if that's not the case, then the price could be or basically it's the other way around. If it is more than 11,500 square feet, then the price could be around 195k, and then so on. If there are more than 2 bedrooms, so on will be the approximate price that the tree is indicating. So this is just an example. This is like a very elementary demonstration of how a decision tree works. There are of course so many other things that come into picture, but I don't want to get into those details, as this is just kind of a very high level introduction that we are trying to do here. Okay, so next is random forest. Random forest in a nutshell is essentially a combination of different decision trees. It's a method where we want to solve a particular problem or limitation of decision tree. That is, decision trees sometimes fit, or basically fit to our training data too well, or in a sense they actually give us biased results. So in order to avoid that, what we do is we take the data set, divide it into different subsets based on a process called bootstrapping, and we take that data set, and for each data set we create a new decision tree. So for example, if we had a data set of 100 records, for example, so we divide that into 10 records each, total 10 data sets, and then we build a decision tree on each of those data sets and predict an outcome. And then what we do is we take a mode value. Mode value is the highest frequency or highest occurring value as output out of all those decision trees. So in this example that I'm trying to use here, it's a very basic, and at a very high level it can explain the concept. So here what we are doing is we have divided the data sets into 4 blocks, and for each block we apply the decision tree and we get an output. Let's say for first decision tree, it's predicting that the output should be a value of 1, and second also is predicting 1, third is predicting 0, and fourth is predicting 1 again. So here, out of these 4 outcomes, the mode value is the highest frequency value is 1, and that is what we are going to predict as output. Now the advantage of random forest over decision tree is it basically eliminates that biasness that that can happen if we are only using one decision tree for on the entire data set. And also because it's an average value, sometimes it adds to the accuracy. If there is one decision tree which is inaccurate in the result like we saw, but all the others, out of these 4, only one was predicting a value of 0, so there is a high probability that there is some this value is not the correct representation, or it's inconsistent of the overall trend, and that's why we do a mode value calculation and we use the mode. Okay, next is something called neural network, or actually speaking it's an artificial neural network. It's basically a model or an algorithm set where we try to predict the behavior of a human brain, how it works, how our brain actually works, where it's a collection of neurons, actually biological neurons, and there are signals transmitted across the neurons, and there is a to and fro communication, and that's how the messaging is done, or messages are passed from our brain. So in artificial neural network we try to mimic a similar kind of concept. Again, I may not be able to go into depth, it's a vast area and vast topic to be discussed, but at a high level, if you just want to understand how it works, is it basically works in 3 layers. One is an input layer, second is a hidden layer, and again there could be multiple hidden layers. At a very basic level, the diagram that you see, it indicates that there is one input layer, one hidden layer, and one output layer. So this in this system, what happens is, an input layer is, we can consider it as our input or the source data. The hidden layer can use all the information coming from the input layer, or maybe just a few nodes, one node, multiple nodes, or all nodes coming from input layer, and apply some sort of mathematical function onto it in the hidden layer and generate an output which could be one or more nodes as the output. So it's like many to many kind of flow, and what it does, what the mathematical function can do is basically perform the required calculations, or perform the required algorithmic transformations to the data to give us the output. Now again, I cannot take a basic example here I mean kind of explain how neural network works. So I would really encourage, if you want to get into the in-depth understanding of neural networks, you can try to research more on this area and try to get some examples from Kaggle or some other implementations that I also have on my GitHub page. Okay, so now again there is one important thing to understand. So basically when I was saying that the inputs combine to form an output using the hidden layer, there is also these connectors that we see. So these connectors could have some sort of weight which can be altered or which can be tuned in order to further add precision or further add accuracy to our output. And this is purely based on an iterative observation approach, where we observe the behavior of the model for different inputs on different weights, and we see which output or which weight combination is giving us the best results. So that's about overall supervised learning. Now coming to unsupervised learning, and I'm only going to touch very briefly on clustering. And unsupervised learning is something exactly opposite of supervised learning, where what we say is it's like learning without the teacher. So here what we have is we have a sample data set, but we don't have we don't have a labeled data set which could indicate, okay, these properties may result in this outcome, and so on. So what we do is what the algorithm actually will do is it will perform some observations or calculations based on that data set itself and try to cluster them. Cluster in a sense, try to group them based on certain observed properties, not based on labeled data. So this is how at a very basic level unsupervised algorithm works. Now one of the most common scenarios is clustering, or one of the most common algorithm that we use under unsupervised model is clustering, where based on like I was saying, based on the vicinity of I mean again how to explain this in a very basic form is, let's say we have this two-dimensional x and y axis plane, or x1 x2 axis plane, and we have distribution of points or data points or the data set which we have got in this plane. Now what we do is, based on we at random choose any of the starting nuclei or starting origin point within this data set, and try to identify the geographical, or sorry, try to identify the geometric distance of each of those points from that nucleus, and those points which are the closest of in the distance, they tend to form a particular group, and then we iteratively repeat and keep on changing the nucleus based on the average distance, and at some point of iteration we come to a point where the nucleus is not changing any further, and that's where we can conclude that we have identified the 3 different clusters of data that we have got. So this is just a theoretical explanation. Again, I would encourage, if you want to get into clustering and understand how the algorithm works, feel free to look out some examples online, or like I said, refer to Kaggle or my GitHub page. There you will find some examples or projects that can like explain this concept in further depth. So that's it in this this video. I just wanted to cover these topics at a very high level for now. Thanks a lot for watching, and I'll try to come up with a new content or new video very soon. Thanks a lot.